Hello, I'm Stephen, and today I'm going to give some calculations of various elasticities. I'll start with the midpoint price elasticity of demand, and that's different to point elasticity of demand, which I'll get to after this example. So with the midpoint, you're working between 2 points, 2 coordinates, Q1, P1, Q2, P2, 2 sets of quantities, 2 sets of prices, and an average between the two. The midpoint formula. And our assumptions are when price elasticity of demand equals to 1, it's unit elasticity. So when price changes, quantity changes, demand changes in equal proportion. When PED is less than 1, it's unit inelastic. So when price changes, there's a less than proportional change in quantity demand. For example, higher prices for fuel doesn't change fuel consumption in the same proportion. It's less than proportionate because you still have to use your car. So when the price increases with inelastic demand, total revenue actually increases. But for unit elasticity, total revenue does fall when the PED is greater than 1. So a good example in the fruit market, the difference between choosing an orange or a pear if the price of the orange goes up and vice versa. That you can easily substitute between the good. So this is the formula for price elasticity of demand using the midpoint formula. It's Q2 minus Q1 in brackets divided by division, Q1 plus Q1 in brackets over 2. So when you see that symbol in maths, that bracket, you do that first before you get to the other. Divided by, this is quite a long calculation, but divided by P2 minus P1, P2 minus P1, so 12 minus 9 here, and then in brackets P2 plus P1 over 2. So numerator, denominator. So now we attempt to get the calculation going, and that's our Q2 and Q1. 30 minus 35. Just substitute these in, sit at your desk and just do it. Divided by 30 plus 35 in brackets over 2. And then with the prices, substitute that in as we mentioned. 12 plus 9, P2 plus 2, and this part of the equation divided by 2. Continuing on, you can see 30 minus 35 is minus 5 over 65, that over 2. Just do this in step by step in transitions. The denominator is 12 minus 9, 3 over 12 plus 9, which is 21 divided by 2. So we've reached that point in the calculation. And now we've got minus 5 over 32.5, find 65 over 2, which is 32.5. Numerator, denominator, 3 over, what's 21 over 2? 10.5. Okay, now we're ready to use our scientific calculator, which I've just misplaced somewhere. Where's that? Oh, here it is. Let's take it off the charger. So here's an iPhone. Turn it on its side, and what you want to do at this point in the calculation is put the denominator in the scientific calculator first. So put 3 over 10.5 first, right? And put that in the memory plus, and then press C to get it all 0. So now you can input the numerator 5 over 32.5, which is that, divided by your memory recall, what's in your memory, and it gives, you should get the correct answer. Let's just do it again. If you've made a mistake, just get the memory recall and press M minus. That will clear your memory, and just double check that it's clear. No, it hasn't been cleared yet. Now it has been cleared. So let's do that again. We know our denominator is 3 divided by 10.5. Okay, you put that in your memory and press C, and then the numerator was 5 minus divided by 32.5, right? That's the numerator, divided by the denominator, MR, and that's our correct answer. So minus 0.54, rounded to two decimal places. So because of the law of inverse demand, all these figures will be negative. So you take the absolute value of that negative value to get the positive value. Absolute value means those two lines there. In maths, absolute value, as a lot of you will know, is turning whatever's negative inside those two lines into a positive figure. So our figure is less than 1, so the good 0.54 is less than 1, so that good is unit inelastic, falling in that range there. The PED is less than 1. Okay, so we conclude that good is price inelastic. So now going over, we'll do another example on elasticity called income elasticity of demand. I'll just check that we're capturing the image okay. Okay, that looks alright. We've got the full whiteboard. So the concept of income elasticity of demand is when income changes, what's the effect on demand? It's called the income effect. The income effect, higher income means more goods demanded. Conversely, lower income means a lower quantity of goods demanded. That's the income effect. It contrasts with the substitution effect, where the price of goods changes, which affects the quantity demanded for that good, and it could even affect the quantity demanded for other goods too. That's the substitution of the difference between the income effect and the substitution effect. So income effect works on income, substitution effect works on changes in price. So we've got two sets of income figures here, $400 per week and $450 per week, only an example. D denotes the quantity demanded. That's the old quantity demanded, which is 300. I'm not expressing that in dollars. And that's the new quantity demanded is 320. So that's the old quantity demand, new quantity demand. That's the old income level, that's the new income level from 400 to 450. So now we go ahead and substitute those values into the equation. D2 minus D1 over D2 plus D1 divided by income 2 minus income 1 in brackets divided by income 2 plus income 1. And that's the formula for income elasticity of demand. Now we go ahead and substitute those values into the equation. So we start with the difference between D2 and D1. Find that in our figures. 320 minus 300 divided by D2 plus D1, so 320 plus 300, divided by income 2 minus income 1, so that's 450 minus 400, divided by 450 plus 400. Then we get to the next step. So what's 320 minus 300? 20 over 320 plus 300, 620 there, divided by, on the price side, 450 minus 400, 50, divided by 450 plus 400, the denominator 850. So we've reached that step. And now you want to use your scientific calculator again and make sure it's clear from the last calculation. So just memory minus, clear it. Just check that it's been cleared. It has, good. So now we want to put this part into memory. So 50 divided by 850 gives you that. So put it in memory and memory plus. Press C to get it back to 0. Now 20 divided by 620 is that, divided by memory recall, dividing by your denominator. And that gives us 0.548, and rounding it to 2 decimal places, it's 0.55. So what does income elasticity of demand coefficient mean? Well, if it's a normal, firstly, this is a normal good, a necessary good. Why? Your assumptions here. If income elasticity of demand is negative, that's termed an inferior good. If income elasticity of demand is 1, say that was greater than 1, it would be a luxury good. If income less than demand, if income elasticity of demand is less than 1, it's a necessary good. But if it's positive, it's a normal good. Okay, so it's necessary if it's less than 1, but if it's just positive greater than 1, it's a normal good. So both necessary goods and normal goods are normal goods, but not all normal goods are necessary goods, because that coefficient is less than 1. Okay, good. So back to inferior good, that's when the price of wheat or rice rises, because wheat or rice took so much of a village's income share that the quantity demanded actually rises because of the income effect. The income effect outweighs the substitution effect. So an inferior good is a unique sort of product, good because as the price rises, the quantity demanded actually increases, such as wheat or rice in the staple diet of a villager, because wheat or rice is such a large proportion. So the income effect outweighs the substitution effect in inferior goods. But most goods, your normal goods, follow the law of demand, where price goes up and quantity demanded decreases, which is the law of demand. Price goes up, law of quantity demanded decreases rather, in the law of demand. Conversely, when price drops, quantity demanded increases in the law of demand. Okay. So when that coefficient is equal to 0, there's no change in quantity demanded. So income elasticity demand is generally not negative, so there's no need to do an absolute value like PED. Don't do an absolute value at all. Keep it the way it is. And again, if you make a mistake, clear your memory, check your memory is clear, clear the memory with memory minus, check your memory is clear for the next calculation if you have one as well. So just check it's clear by pressing memory recall and then 0. If nothing comes up in memory recall, you've got a clear memory. Okay. So also, if back to this, we concluded it's a normal good as categorized as a necessity good, 0.55. But if that was negative, that would be an inferior good. Quite rare actually, inferior goods, but they do exist. And if our calculation was greater than 1, that would be a luxury good, a luxury saloon, an old restored Jaguar, where the price increases, the quantity demanded actually increases, luxury good. So now we can go over to cross elasticity of demand, just on this whiteboard, which I'll mount here on the bracket. You may have to calculate cross elasticity of demand. What we mean by cross elasticity of demand is we're looking at the effect of the change of one price on one good, what happens to change in quantity demanded with another good. And we're checking to see if those goods are either complementary, they go well together, such as a motorbike and a motorbike helmet, or substitute goods, that fruit example, where oranges substitute for pears quite easily. So if that cross elasticity of demand figure is positive, it's termed a substitute good, okay? But if the figure is negative, then we know those two goods that we're studying are complementary goods. The goods go well together. So in my example, good 1 is a product called Super Tape that you could buy at a hardware store. And that's the Q1, Q2, which we ignore because we're only looking at the price. Yeah, so the handy tape is the second good. We want to see if Super Tape and handy glue are either substitutes or complements. In my notes here, only the handy tape price is unchanged, but the Super Tape price does change. Okay, so the Super Tape price has changed. It's gone from $13 up to $16. So we consider a price change with Super Tape. Ignore the quantity for Super Tape because we won't need that in the calculation. Just cross it off if you help. It helps you remember just to focus on the price change. Now we're looking at the quantity demanded for the other product, handy glue, because of the change in the other product, Super Tape. So we've got two sets of quantities for handy glue. We start with Q1 16, Q2 14, and this time round disregard any glue prices if you're given it. So just cross out any glue prices. Here you crossed out the quantity of Super Tape. Here you'd cross out the prices of handy glue if it was available. So you don't get confused. So step 1 is price change in Super Tape, and you're looking at quantity demanded of handy glue, the other good. So here's our formula for cross elasticity of demand. CED between good 1 and good 2 equals Q2 minus Q1 over Q2 plus Q1 over 2 divided by P2 minus P1 over P2 plus P1 over 2. Okay, again quite long, and we've just got to do it step by step. So now plug in the values first of all, what's Q2 and Q1, the quantity change of the handy glue? Well, we said the Q1 was 16, okay, so put that there. Q2 was 14. Find the difference in the next one, minus 2. Put it over 14 plus 16, which equals 30 over 2. Divide that by the price part of the equation, focusing on the price change of super tape. So P2 of the super tape is 16 minus $13, yeah, divided by 16 plus 13 over 2. So we've reached that point. It's just about methodically doing it step by step. So minus 2 over 30 over 2. Leave that as is. Divided by 3 over 29.2. Yeah, 16 plus 13 equals 29 over 2. We've reached that step. And now we simplify more the denominator. Simplify the denominator. Minus 2 over 15. 30 over 2 is 15. Divided by 3 over, what's 29 divided by 2? 14.5. And now we solve with our scientific calculator again. Putting that in the memory of the scientific calculator. Memory plus. Calculate the numerator first. Clear it so it goes back to 0. Don't clear your memory, just clear the screen so it goes back to 0 on your screen. Put the numerator calculation first, minus 2 over 15, divided by memory recall. And then you get that figure minus 0.64, I should say, to 2 decimal places. So that's a negative figure for cross elasticity of demand. So when the price of super tape changes, the quantity demanded of the other good handy glue is favourable for complementarity. So that means that both super tape and handy glue are complementary goods, okay? They go well together, the tape and the glue. Perhaps they wouldn't have been such good complements if the glue damaged the tape or something, if there was a wrong chemical reaction which damaged the tape, but everything's fine for using those goods together. So we've concluded they're complementary goods and not substitutes. That would be a positive answer. So if you're under a bit of a time constraint, you're running out of time, you might not have time to double check that or any errors you've got with memory recall. You might have got sufficient marks at this point and the examiner won't castigate you too much if you've got an error in your calculation and you haven't got time to double check. But if you are going okay for time, go ahead and double check and get on to the next question, okay, which happens to, for us, happens to be on the other whiteboard. I'm going to go over arc elasticity of demand. Now, arc elasticity of demand is the same as that midpoint formula for price elasticity of demand, but I just want to explain arc elasticity of demand so we're clear on the concept. Hopefully that won't fall. I'll just check if that little whiteboard is... Might just bring the tripod down slightly. That's it. Great. So with arc elasticity of demand, again, it's a movement along the demand point from 2 points A to Z, and you're calculating the average, the midpoint. That contrasts with point elasticity of demand. You might have seen this, where PED on the point method is equal to Q2 minus Q1 over Q divided by P2 minus P1 over P1. Another expression you might have seen is It's the percentage, the first derivative of Q over, with respect to P, multiplied by P over Q. Or you might have seen elasticity, point elasticity, change in quantity percentage over change percentage, price percentage. That's point elasticity. And I've even given an example here, 2 quantity demand is 2 price. You substitute that in an easier calculation, 10 minus 8 over 8 and 12 minus 9 over 9. Do that and you'd find the absolute value minus 0.75 absolute value. It's 0.75. So that's less than 1. That's inelastic. So as price increases, so does total revenue. That's point elasticity of demand. What this is arc elasticity of demand. Point elasticity is only on one point, an infinitesimal change. Arc elasticity is a whole scale change along the demand curve from one point to the other. It's used for pricing decisions, whole scale changes in prices. So my example, I'm considering a glass of champagne at the opera, and I'm comparing the Sydney price and the Melbourne price for a glass of champagne at the opera. At Sydney, I said it was $12 a glass for champagne, with quantity demanded 40. In Melbourne, they dropped the price to $10 a glass for champagne, 60 units demanded. So we're going from A to Z along the demand curve. That's the Sydney bundle. That's the Melbourne bundle. We're moving from that point to measure elasticity along here, the midpoint between the two. So still our pricing decisions, elasticity equal to 1 is unelasticity, elasticity less than 1 is inelastic, elasticity greater than 1 is elastic. We want to find what this one is. So that's our formula, the same as the formula for midpoint price elasticity demand earlier. I just wanted to outline some more concepts graphically. So Q2 minus Q1 over Q2 plus Q1 over 2 divided by P2 minus P1 in the numerator, denominator divided by P2 plus P1 divided by 2. So again, substitute those values in to the equation, work it step by step, use your memory recall for the denominator, clear the memory if necessary with your M minus key, check that it's been cleared a couple of times, that it's 0 if you've made a mistake with memory. Do all these steps and we find that the arc elasticity of demand is the absolute value of minus 2.2. So in effect it's 2.2, turning negative values into positive. Why use the absolute value? Again, because of the law of demand, price and quantity demanded is inverse. So I did this same calculation moving from Z to A, and I got the same figure. Because it's an average, it's the midpoint, so you would expect it to be the same. So just differentiate between arc elasticity of demand and point elasticity of demand. Again, that's point elasticity of demand, that's arc elasticity of demand. And yeah, so what I've tried to do, I've tried to explain some concepts of 4 types of elasticity calculations. Price elasticity of demand with the midpoint formula, income elasticity of demand, remember the income effect, also cross elasticity of demand, effect of one good price changing on the other goods quantity demanded, 2 goods in the same aisle in the hardware store. And also just clarifying what arc elasticity is. It's the midpoint between those 2 points, not the whole demand curve midpoint, but only the midpoint between those 2 points. You are calculating arc elasticity of demand at that precise midpoint between the two midpoints only. So I hope that you found that useful. I'm Stephen Mack from TEFAT Economics Tutoring in Sydney, and I hope you found this helpful, this presentation, and see you next time. Bye.